This is STATA Training 1, Part 2. In Part 2, we're going to focus on Objective 3 to estimate summary statistics and Objective 4 to conduct inference testing. So coming back to our do file, we can now come to Objective 3, which we have is summary statistics. So summary statistics are just ways that we can summarize the data with certain numbers, such as a mean, a standard deviation, a distribution. So the first thing we want to be able to do is load a data set. So I want to actually load this wages 2 data set, so I can just copy this right here and paste it right there. So now it's going to go through these files, but it's going to load this one here. So when we think about summarizing the data, one of the best ways to summarize data to start is to look at the average. And so if I do this, I can do a command that's called summarize, or I can do sum for short, and I can summarize a variable. Let's just summarize wage to start. So I can run my do file. It's going to load the data set, and now it's going to summarize the wage. So in this, I have 935 observations. The average wage is $957. Now you think, is that per hour? Is that per month? When I look over here at my variables, many variables will come with a label. So wage is monthly earnings. So this tells us the average monthly earnings is about $957. It also gives us a standard deviation, a min, and a max. So doing a sum command is a great way to summarize and look at the average, the mean, and the standard deviation. Another thing we can do is we can do sum wage. I can then add several variables, so I don't just do wage, but I can also do hours, education, experience, and tenure, years at the current job. So I can do several summary commands, and it'll create a table with all of them in this. So each of these have 935 observations, and it gives me the mean or the average of each of these different variables, the standard deviation, min, and max. So that can be a very useful way to do that. Now all of these are continuous variables in the sense that they start and they go by ones. I can also do sum married. I can do a summary statistic on a dummy variable or a binary variable. It's a 0 or a 1. And this will tell me now 89 is the fraction of the sample that are married. So 89% of this sample are married. The other 11% are single. So I can do different summary statistics with that. The other thing I can do, in addition to summarize, is I can do tab. Now one thing is we've done all of our things here in the do file, which is very helpful, but I could also type them straight into here. If I don't want to just run the do file every time, I can do tab education. And this will then just run it command by command. So oftentimes you might want to try different variations here before you settle what to do in your do file, especially when you're doing summary commands. So this shows me like the distribution of years of education. So 1% of the sample, or 10 observations, have 9 years of education. 3.74% have 10 years of education. So tab can be a very useful command to look at the distribution. So these are going to look at average means and standard deviations. Sum will do that for you. And then tabulate, or tab, will look at distributions. And again, I'm trying to annotate so that when I come back, I know exactly what I'm doing with each line of code. So if I do tab education and I run this, now it'll give me the distribution of education. Well, the other thing you can also do is you can do what's called a cross tabulation. So let's suppose I want to do, so I can do a actually I'll just do it here because it's within the same, tab education married. So by doing this, it'll break it apart by to say, okay, here's the years of education on my left side. On my right side, here are the individuals who are single, and then individuals who are married, and it'll show you the breakdown of who these are. So now you can go to help tab, and then this will be a two-way tabulation. This will give you many different ways in which you can then do different types of things within tabulation. As you scroll to the very bottom, this will give you now different examples of how to do that. So web use is a data set loaded already in Excel or in STATA. So if you do this, then you can just run these on this data set city temp 2. So one thing that's very kind of helpful is row no frequency. So to show you what that does, so I can just copy this command here, do comma row no frequency, and this will now treat it by row and then give you the percent and not the count. So frequency is the count. So this means among 9 years of education, 100% of those individuals are married because 10 out of 10 are married. And so it's just a different way to display the data using frequencies or using percentages rather than frequencies or counts. So that's what we have in terms of doing objective 3, which is just summarize the data. There's so many more ways that you can do this. You can do histograms, you can do densities, but those are the 2 most common commands we'll use are sum and tab. So now let's go to objective 4, which is inference testing. So inference testing allows us to do testing against different population parameters. So let's suppose someone is considering whether the average years of education in the country is 13 years. So let's suppose somebody says on a news report, the average American has 13 years of education, and you want to test that. Well, you can do that. So I can conduct a test if education equals 13 years. So maybe before I do that, I'm just going to do sum education. Well, the average here is 13.4, but the question is that statistically different than just 13? So I can then do a t-test, and then say educ equals 13. And this will run that test for me. Oops. So here it'll give me my average. It's a t-test where here is the 2-sample p-value, and here is the t-stat. So with a t-stat greater than 1.96, which is the 5% level, we would reject the null. P-value, you can just compare this to 0.05 or to 0.01 or whatever p-value we want to use, or alpha we want to use. But in this case, we would reject the null that the average education is 13. Well, let's suppose instead that you read that it's actually 13.5. So I could conduct a test if education is equal to 13.5 years. And now I run that test, and notice now that the t-stat is below 1.96, the p-value is high, so I would fail to reject the null and say that this is not statistically different from this population parameter. So I can do a test against simple numbers. I can also do test between 2 sample means. So let's suppose that rather than just one population parameter, somebody says, ask the question, do single and married individuals have the same wages? So I want to test if wages are different by marital status. So to do this, I can do the same thing. I can do t-test is the command I'm going to use. And here is the outcome is wage. And now I do an option, comma, by married. So this says test whether wage is different by the marital status. So I run that, and this will tell me the average wage for single individuals is $798. The average monthly earnings for married is $977. The difference between that is $178, and the t-stat is negative 4.2. So this again we would reject at the 5% level. We can also compare this to our p-value, and I would reject the null accordingly. So these are the most common ways in which we can do t-test. We're going to test against a single parameter, or we're going to test the sample means between 2 different parameters by a group. Now the key with this group is it needs to be binary. It needs to have 2 outcomes, 0, 1. I can't do a t-test wage if there are 3 or 4 different outcomes for this variable. So again, that's the syntax, and that's now our 4th objective, where we have just conducted some inference testing within STATA. Now I'll leave it, if you're not very confident with your inference testing, I'll leave it to you to look up how to interpret the t-stat and p-value. It's assumed that you know that. But now we can go through and do basic summary analysis for STATA with training 1.